Okay. Good morning, 8th class students. Today we are going to learn one of the important concepts in vectors. Its name is dot product. So, dot product of vectors. So, the dot product of vectors is defined as mathematically it is defined as the product of magnitude of the vectors and cosine of the angle between the vectors. Product of magnitude of the vectors and cosine of the angle between the two vectors. If A bar and B bar are two vectors, see students, A bar is a vector and B bar is another vector. So A bar is one vector and B bar is another vector, and let us consider that the angle between the two vectors is theta. Consider that angle between the two vectors is theta. This is the A bar vector and this is B bar vector. Then the dot product of these two vectors is defined as product of magnitude of the first vector. A bar is a vector, its magnitude is A. B bar is a vector, its magnitude is B. And cosine angle between the two vectors. There will be some angle between A and B. See, this is the initial point O. At this point, so A bar vector is started, B bar also started. So then this is the initial point of B bar and like this. So cosine angle between them we have to take. So that is the definition of dot product. It is defined mathematically like that. So now see, we can discuss some of the important points related to the dot product and its geometrical interpretation also. Now we know that, see students, this is a vector we know. A bar, B bar is a vector we know. So it is lying, so it will have two components. So because it is lying in the plane, so we can write, see, this value I can write it as B cos theta. So this value I can write it as B cos theta. This side I can write B sin theta. Now the name of B cos theta is called, see what is the name of B cos theta here, see students. So B cos theta is, B cos theta is component, it is the component of B bar vector, component of B bar vector in the direction of what is that students? In the direction of A bar. See students, this is our vector B bar, this is our vector B bar, and its component is B cos theta. This B cos theta is in the direction of A bar. So that's why B cos theta is one of the component. This B cos theta is one of the component of B bar vector which is in the direction of A bar. Or otherwise another name is also there. So B cos theta is projection of B bar. It is also called projection of, so what is that? Projection of B bar along A bar you can call. So it is lying in the plane. This is a vector, it is lying in the plane. So it will have some component in this direction and it will have some component in this direction also. You can resolve into two components. This we have discussed in the resolution of a vector. Okay students, so the B cos theta name is, what is the B cos theta name? It is the projection of B bar along A bar. So now I want to get its formula. See, the dot product is defined as, so A bar is a vector and B bar is a vector and angle between them is theta. Then, so how we are writing, students? How we are writing? A bar dot B bar is equal to, so A into what can you write? A into B cos theta we can write. So we can write A into B cos theta. Okay, and B cos theta name we know here. Okay, students. Now the B cos theta name is what? Projection of B bar along A bar. Now this B cos theta I want to make subject. So make B cos theta as a subject. Then B cos theta, so is equal to, what will you get, students? A bar dot B bar by A. So that is projection of B bar along A bar is, so what are you getting? Projection of B bar along A bar. So means that is B cos theta. That is B cos theta. We want only B cos theta. Then B cos theta only we want. Then that will become only B cos theta, you leave it. Then A bar dot B bar by A it will become. So means, so A bar dot you have to read it. A bar dot B bar by, so magnitude of the first vector. So that is called A. So this is called projection of B bar along A bar. That is equal to this much. Similarly, you can write it. Similarly, we can write it. So what is that, students? Projection of what is that? A bar. You can write the projection of A bar. So along B bar I want. So along B bar I want. So that is, okay, projection of A bar along B bar. So that is called A cos theta. Okay, students, that is A cos theta. So how do we will get, you see, students? Projection of A bar along B bar. Okay, students, see, consider this is a B bar vector. It is a B bar vector, and this is a bar vector. Let the angle between, so angle between both the vectors is theta. See, A bar is started at O point, A bar is started at O point, and B bar also started at the O point. Both have the same initial point, co-initial point. Then the angle between them is called angle between the vectors. This is called angle between A bar and B bar. Now draw one perpendicular to B. So then this can be written as, if this is a right angle triangle, this is A bar vector. A bar is a vector. Its magnitude is A, and its magnitude is hypotenuse length is A. Its component in this direction is A cos theta. This A cos theta is in the direction of B bar. That's why, what will you call A cos theta? Name is what, students? A cos theta name is what? A cos theta name is projection of A bar along B bar. So A cos theta name is, what is that? Projection. So projection of A bar, projection of A bar along B bar. So now I want this value. and this is a vector A bar, this is a vector B bar, then the dot product of A bar dot B bar is defined as magnitude of first vector into magnitude of second vector into cosine angle between them. So you have written cos theta, and this can be written like this also. So A into cos theta, and you have here B. So fine, this A cos theta name is what, students? Projection of A bar. So means, so I want that A cos theta. So make A cos theta subject. Make A cos theta subject. Then A cos theta is equal to, so what do we have here? A bar dot B bar. So A cos theta is equal to A bar dot B bar by, you will get B. This is the component. A cos theta is the projection of A bar along B bar. So that is the formula, you got it. So and dot product is also called, it is also called as scalar product. It is also called as scalar product. So in physics, while multiplying some physical quantities, while understanding the concepts in the nature, sometimes we have to multiply some physical quantities. While multiplying those physical quantities, if the product is a scalar quantity, then it is called dot product. So dot product of those two vectors, when two vectors are multiplied, and if you are getting a scalar, it is called dot product. So dot product is also called scalar product. Another name of this dot product of vectors is, okay, dot product of vectors, or you can also call it as scalar product. So now, so the examples of this dot product of vectors we can see, students, that is called physical interpretation. So far we have seen the geometrical interpretation, and how does the dot product defined we have seen. Now we can go for so physical interpretation of scalar product. So physical interpretation of scalar product. See, students, now consider a plane. So I am considering a plane. So x-axis and y-axis, and here so we know the definition of work. So in the physics language, work is defined as the product of, so what is that? Force. So product of force into displacement. It is defined as the product of force into displacement. Okay, then work done, W is equal to, work W is equal to force F bar dot displacement, we can write it as, so delta R bar. Okay, so delta R bar means, for example, see, you consider that initially a particle is at this point. This is the position of the particle. So P1 is the position of the particle with coordinates x1 comma y1. So we are telling its position in this plane with this as the origin. So see, we are telling the position of the particle. It is at some x meters distance and y meters distance along y axis. This is the y units distance and this is the x units distance. You are telling the position of a particle. You are telling the position of a particle. A particle is here. It is at what height? You are telling from this line. This line is called x-axis. This line is called x-axis. It is at what height from this line you are telling, and that line is parallel to y-axis. So that is called y-coordinate. And this particle is at what distance from the x-axis? The particle is at what distance from the x-axis you are telling. So from the y-axis it is at what distance you see from this line that is parallel to this one. So this is called x-coordinate and this is called y-coordinate. And the position of this particle P1 from the origin O. So this is called initial position vector R1 bar. So here R1 bar. So R1 bar is equal to, it is started at O and set P. So you are telling its position from O, that is called OP bar. That OP bar can be written as x units. So OP bar, so x into I cap plus y into j cap we can write. That is called position vector. And similarly, after some time this particle reached to here. So after some time it has reached to here. Let us consider that it has reached to here. So now this is the position of the particle P2. It has two coordinates x2 and y2. So means you are telling its position from the origin. This is called R2 bar. So this is called R2 bar. Okay, see students. So the particle has gone from here to here. So like this. So this is the P2 position. This is the P1 position. Okay. So this is the initial point. This is the final point. The line joining from initial point to final point. So final point is called displacement, which is called delta R bar. So which is called delta R bar. So delta R bar here delta R bar, how do we write? Delta R bar is equal to, we will write it as R2 bar minus R1 bar. So final position minus initial position we have to write it. Okay students, so dot product examples, work done. So work done in the physics terminology, work done is an example of dot product. So which is called physical interpretation. Examples we are seeing. So examples of dot product. So work done is an example for dot product we know. Okay students. And see my dear students. So now, then the work done is written as F bar dot delta R bar, that can be written as R2 bar minus R1 bar. So this is one of the example. Work done is a product of two physical quantities, force and displacement. The dot product of force into displacement gives a new physical quantity which is called work, which is a scalar. So work done is an example for dot product. So it is one of the example we have seen. And R2 bar, this is the final position you are telling, and again it also will have two coordinates. So this is called x2, this is called y2. So R2 bar also we can write x2 into I cap plus y2 into j cap, and here this is x1 into I cap, y1 into j cap. So the difference we will take. So then you will get, so this is the initial position, this is the final position. The direct line segment drawn from initial point to final point gives the displacement. So you got it. This is the first example for, what is that? Dot product. And second example for dot product is power is equal to, power is equal to, we will write work by time. So the definition of power is equal to work by time. And you know that work means what will you write, students? F bar dot delta r bar. That is called displacement vector. Delta r bar by time. So this displacement by time can be written as velocity. So that is, then it will become F bar dot, so force F bar dot, so what to write? V bar. Here, so here delta r bar by t is called what will you write? Velocity vector V bar. This is the displacement here. So this delta r bar is called displacement. Delta r bar name is displacement. So displacement means delta r bar name is what do you know, students? Displacement. Displacement, you can write it. So displacement means final position minus initial position. That's why this delta r bar is equal to, you can write it, final position minus initial position, r2 bar minus r1 bar. This is the initial position of the particle and this is the final position of the particle. So this is called delta r bar. Okay, students. Okay, so what is the dot product definition we have seen? And examples of dot product, we have two examples for the dot product. One is called power. So that power is equal to F bar dot V bar. So it is, so power is a scalar physical quantity. It is the dot product of force into velocity. And similarly, another example is work done, which is the dot product of what is that? Force into displacement. The dot product of force into displacement we have seen. Now we can see properties of the dot product. These are very important. Scalars and kinematics lesson, that is vectors and the kinematics lesson is a very basic concepts for all intermediate, IIT, JEE, NEET and all some other competitive exams also. These will be useful for you. So please listen carefully, my dear students, and practice on the same day only. So take it very serious. Okay, now examples. So now properties of dot product. Properties of dot product. Okay, the dot product obeys commutative law. So it obeys commutative law. It obeys commutative law means A bar dot B bar is same as that of B bar dot A bar. So dot product is commutative in nature. It is obeying what is that? Commutative law, or it is commutative in nature also you can call it. It is commutative in nature. And second one is, and dot product is it follows distributive law also, obeys so, and next one is the dot product is distributive. So means it obeys distributive law. It obeys distributive law. So that is distributive law in sum. It obeys distributive law in sum. Means A bar dot B bar plus C bar is same as that of A bar dot B bar plus A bar dot C bar. So this is called distributive law, that is in addition. So commutative, it obeys commutative law, it obeys distributive law also. And next one, if theta is 0 degrees, so next point, if theta is 0 degrees, means if the angle between two vectors is, if theta is 0, means that is two vectors are parallel. That means two vectors are parallel. So A bar and B bar are parallel to each other. Theta is 0 degrees. Then cos theta, that implies cos 0 degrees, that is equal to 1 we know. Cos 0 degrees value is 1. So then if theta is 0 degrees, two vectors are parallel to each other. Two vectors are parallel to each other. Means A bar and B bar in the same direction. So then A bar dot B bar is defined as A bar dot B bar is equal to magnitude of A into magnitude of B into, so cosine angle between them. So since A and B are parallel to each other, so theta 0 degrees, theta is 0 degrees, cos 0 degrees value 1. So cos 0 degrees value is 1. So that is equal to, I will get AB. So I am getting AB. A bar dot B bar is equal to simply A into B. So means it is a simple product of A and B. That is simple product. So that is simple product of A and B, magnitude of A and magnitude of B. So when the angle between the two vectors, so properties we are seeing, if theta is 0 degrees, two vectors are parallel, A bar and B bar are parallel. Okay, so then see dot product of vector itself. So dot product of a vector itself. So next one is dot product of a vector itself. So dot product of a vector itself means A bar is one vector, and again I am doing the dot with the same vector only. A bar dot A bar I am doing. A bar dot A bar is equal to magnitude of first vector A into magnitude of second vector into, So cosine angle between them. Both are same vectors. Angle between them is 0 degrees. So that is, so A into cosine angle between them, cos 0 degrees value 1. That is A square. Means dot product of a vector itself is equal to A square. That is equal to dot product of a vector itself is equal to square of the magnitude of the vector. Dot product of a vector itself is equal to, what is that? Square of the magnitude of the vector. Square of the magnitude of vector. Magnitude of vector, we got it. So means A bar dot A bar is equal to A square you are writing. So what is the result we got it, students? The dot product of a vector itself is equal to square of the magnitude of the vector. Similarly, B bar is a vector. Again you do the dot product with B bar dot B bar, you will get B square. Okay students.